All right, guys, so today we are starting Unit 6, and today's lesson is going to be on function notation. For your essential question, I would like for you to explain how to evaluate functions that are in function notation. So here we have an equation like we've seen before many times, where we have an x and a y value, and we have here a table of values. So what I want to look at first is what happens when we plug numbers into this equation. So we have seen before that the x is our input value. So we're going to input numbers for x. So for this one, we're going to input 1, 2, 3, and 4. And then our output, what we get from that input, is going to be the y value. So if we take 1 and we plug that in for our input, we're going to have y is equal to 3 times 1 plus 1. So we get that y is equal to 3 plus 1, which is 4. So our output value for that would be 4. When x is 2, that's our new input value. We have y is equal to 3. We input 2 for x. We get 3 times 2, which is 6, plus 1, and that gives us 7. Y equals 3 times 3. Input value is 3. That gives us 9, plus 1, which gives us an output of 10. And lastly, we have y is equal to 3 times 4 plus 1. 4 is our input, and our output here is 13. So again, the x is our input value. We're inputting numbers in for the x, and what we get from that is our output value, which is our y value. So function notation is the way a function is written. So you'll be given equations that look something like this. F of x is equal to 3x plus 1. And so what happens here is the y gets replaced with f of x. Now, the reason we do this is because if we put multiple functions on a graph, we have to have a way of naming them. We can't call all of the functions that we put on the graph y, because they're not all the same value. So we can't have a parabola and a line and everything all on the same graph and call them all y, because they're all different functions. And so using function notation allows us to name our functions using different names. So again, the f of x replaces the y. So this now becomes our output value. And the x is still our input value. And this is the expression that gives us our output value. So we're still inputting numbers in for x, and our output value is still going to be what we get from that. But instead of saying y, if we plug, say, 7 in for x, it would be written as f of 7. So what happens there is we're replacing the x with 7. Our x value is then 7. So we could write it as f of x is equal to 3x plus 1. And again, whatever you plug in for that x value, you're going to plug in for all of the x values. So f of 7 will have a different value than f of 1, because for f of 7, you're inputting the 7. For f of 1, you're inputting the 1. So again, those are going to have different output values, and those output values will be represented by what you plug in for x. So f of 7, f of 1, etc. We could replace the x with a different variable. We could say f of a is equal to 3a plus 1. So again, wherever there's an x, we would then replace that with an a. And again, f of 5 would be equal to 3 times 5 plus 1. So again, here's a table of values to represent this function over here. So we saw this on the previous slide. When x is 1, f of 1 will equal 4. When x is 2, f of 2 will equal 7. When x is 3, f of 3 will equal 10. When x is 4, f of 4 will equal 13. When x is 5, f of 5 will equal 16. So that's how we can read from the table of values given our input and our output values. So here we're given 3 different functions. Again, we can use those different functions as the names of the function. So if I were to put these 3 functions on a graph, they would all have different, they would all look differently. Clearly, f of x and h of x are going to give us parabolas, and g of x is going to give us a line. So they're all going to look different on the graph, and we can use the names f of x, g of x, h of x to name those functions on the graph. So here we have different questions that we're being asked about the different functions. So for the first one, we're given f of 5. So what this is telling me is to use function f, and what we're going to do is we're going to input the 5. So f of 5 will be equal to, we replace all of the x's with 5. That's going to be 5 squared. Again, don't forget to use parentheses when you're plugging numbers in. Minus 6 times 5 plus 3. And we simplify that. So that's 25 minus 30 plus 3, negative 5 plus 3, and that gives us negative 2. So f of 5 is equal to negative 2. For part B, we're looking to use function g, and we're given an x value of negative 4. So g of negative 4, we replace all of the x's with negative 4, is equal to a negative 4 plus 7. That's going to give us a positive 4 plus 7, which gives us an output value of 11. So again, g of negative 4 is equal to 11. For C, we're looking to use function h when x is 7. So h of 7 is going to equal, we replace the x with 7, negative 7 squared minus 12. That's going to be negative 49. Remember, square the 7 and then times it by a negative, minus 12. And that's going to give us a negative 61. All right, for this one, it looks a little bit different. We're being asked, when does f of x equal negative 2? I'm going to clear my screen for So when does f of x equal negative 2? What we're doing here is we're looking for the x values when f of x equals negative 2. So we're replacing this f of x now with negative 2, and we're solving for x. So we have negative 2 is equal to x squared minus 6x plus 3, and we're solving for x. So here we apply what we learned in the last unit with solving quadratics to solve for those x values when our output value, our f of x or our y value, is equal to negative 2. So we're going to add that 2 to both sides. That gives us x squared minus 6x plus 5 is equal to 0. And from here, we need to solve. So we can either factor or use a quadratic formula. So I'm going to check to see if this is factorable. Factors of 5 that add up to 6, that's going to be negative 5 and negative 1. So it'll be x squared minus 5x minus 1x, or just x, plus 5 is equal to 0. Factor out the x from the first group, that leaves us with x minus 5. Factor out the negative and just a 1 from the second group, and that leaves us with x minus 5. So here we have x minus 1 times x minus 5 is equal to 0. Set each factor equal to 0, each of our binomial factors. So x is equal to 1 and x is equal to 5. So when does f of x equal -2? When x equals 1 and when x equals 5. Now remember that this is a quadratic, so this gives us a parabola. So in all cases except for the vertex, we're going to get two x values for that one y value. All right, same thing. Let's look at E. When does h of x equal -37? So we're looking for the x value when h of x is equal to -37. We're replacing that h of x with -37. It's equal to -x squared minus 12. Now notice here we have no b value, so I'm going to solve using square roots. Again, quadratic formula is an option. So this is going to give us -25 is equal to -x squared. In order for me to square root, I have to get the x squared completely by itself. So this negative has to leave. So I'm going to divide both sides by -1. I get 25 is equal to a positive x squared. And now I can square root both sides. And I'm going to get x is equal to square root of 25. It's going to be positive -5. So when does h of x equal -37? When x is equal to 5 and when x is equal to -5. All right, for this one, we are using a table to find our x values or our f of x values, to find our input or output values. This is pretty straightforward. We're just strictly looking at the table to make these determinations. So here, what is f of 4? So our input value is 4. What does f of 4 equal? So when our input is 4, our output value is 35. So f of 4 is equal to 35. What is f of 1? So again, our input value is 1, and our output value will be 11. When does f of x equal 25? Here's 25. When f of x is equal to 25 when our input value is 3. So when x is 3, our f of x, our output is 25. So f of 3 technically is equal to 25. And when does f of x equal 47? F of x is equal to 47 when x is 5. Again, really straightforward. It's just a matter of understanding what you're reading. So again, if your x value has been replaced, you're looking for the output value. We already have the input value. We're looking for the output value. If we're given the output value, we're looking for that input value or that x value. All right, one more GP. All right, looking at the graph, we're now going to make those determinations. So here, again, we're given the input value. So we're given an x value of -6. What is f of -6? So we're looking for the output value or the y value of the function when x is -6. So we're going to go to our graph where x equals -6, and we're looking to find on the graph what the y value is when x is equal to -6. So we go up to the value of -6 that's on our parabola, which is right here, and we look for that y value, and that y value is +3. So f of -6 is equal to 3. When x is -3, so again, our input value is -3, our output value or our y value is 12. When does f of x equal 3? So for what input value, for what x value is our output value 3 or our y value 3? So we look on the graph where y equals 3, which again is here. So what are the x values for those 2 points on our graph? Well, the x value for this point here is 0. and the x value for this point here is -6. So we can see here that we have the same values, because in this case we were given the input and we get an output of 3. In this case we were given the output value and we find the input value of -6. But you have to be careful, because in this case, again, because it's a parabola, we have those two y values. I'm sorry, we have those two x values for that one y value. Again, what is the input value or the x value when the output or y value is 8? So we look at the graph. Here's our y value of 8. We have 2 points where y equals 8. So what are those x values at those 2 points? Well, x is equal to -1 and x is equal to -5. And that is the introduction of function notation. Don't forget to answer your essential question.